My name is Steve Eckerman. I'm a master's student at Ohio University working on my thesis here with the U.S. Fish and Wildlife Service and the Student Conservation Association at the Great Meadows National Wildlife Refuge Concord unit, the impoundments here. There's two approximately 100-acre impoundments separated by a dike. And each year the impoundments are the water levels at the impoundments are manipulated mainly for migratory bird habitat, so that the vegetation can germinate and reproduce, and also to control the water chestnut here at the Great Meadows, which is an invasive species. So what I'm looking at, what my research question is going to attempt to answer, is how the water level manipulations affect the growth and movement of head start and adult female Blanding's turtles. The lower impoundment this year will be lowered, which is the water flows in that direction. So the lower impoundment is to my left and the upper impoundment is to my right. The upper impoundment water level will not be manipulated at all. And we have head starts and adult females in both impoundments. So once the lower impoundment is completely drained, we'll see whether or not the head starts and adult females estivate, meaning they just dig down and basically don't eat and just stay put in the mud for the duration of the water loss. If they congregate, so all the turtles attempt to get to what water is available, the small pools that will be available, or if they migrate, if they, upon drawdown, simply take off and try to find other water, such as the upper impoundment. So I will also check every turtle in the upper impoundment and see how their growth is, and see whether or not the growth of the turtles in each impoundment differs. So possibly if the turtles do estivate or congregate in the lower impoundment, their growth will be significantly smaller than the ones that are in water that has not been manipulated. Is when you put a transmitter on an animal, in this case a freshwater turtle, and then it sends out a signal based on a particular frequency. It sends out the signal continuously, typically, to a receiver, which you can type in a frequency and then it would just beep so that you can follow the individual. Well, one thing that's unique to the Blanding's turtle, well, most turtles are long-lived species and they become mature at a late age. The Blanding's turtle in particular does not become mature until it is between 17 to 20 years old, which means that it has to survive a fairly long time before it can contribute to the population, which is fairly difficult to maintain a population. It's also, in this particular area, losing a lot of nesting habitat. It typically needs to nest in open areas, and now with all the houses and the forest coming back and no longer having a lot of agriculture, its nesting habitat is disappearing. Well, what I'm actually researching is whether or not the drawdowns at these impoundments are affecting the growth of the head starts of juvenile Blanding's turtles. So because we have transmitters on each turtle, I can find them on a weekly basis and take their weight and measurements to determine if they're growing or if they are losing weight because of the loss of water. We drain the impoundments mainly for migratory bird habitat, so it's necessary to do for all the migratory birds that use this in their fall and spring migrations, but we have a feeling that it may be impacting the Blanding's turtle population. So hopefully by answering that question, we will be able to manage the impoundments to help the Blanding's turtles. But also, having transmitters on the females and following them, we're able to protect their nests so that so the turtles can hatch before being predated by coyotes and raccoons and various other predators. This is an adult female Blanding's turtle. This particular turtle was marked probably sometime in the 70s, early 80s. So we know that this particular individual is probably greater than 50 years old, maybe 60 years old. We have these transmitters on them so that we can track them using a receiver. This sends out a continuous signal on a particular frequency that I can punch into the receiver and then find each individual turtle. We have approximately 30 adults and 20 head starts that we have transmitters on, like this one. I'm going to go ahead and process this turtle. Each time I catch an individual turtle, I weigh it and take measurements on its carapace, which is the upper shell, and on its plastron, which is this bottom shell. And then I take a GPS point at each location so that I can later map it using geographical information software. So I'll go ahead and weigh it and measure it, and I collect everything on a data sheet. This is a digital scale that's accurate to the gram, up to 2,000 grams. And I typically weigh them 3 times and then take the average. And this female weighs 1,433 grams. I catch this individual every other week. So these are called calipers that I use to measure the turtles. The adults aren't really going to change. You can just pretty much measure them once, twice a year, but I do measure them every other week. The more often I measure them, the more accurate we'll be in the end when I analyze my data. These calipers go up to 50 centimeters. The average adult female is 20 to 25 centimeters. And this particular individual already nested, so we followed it to her nest. But typically throughout June and late May, we can reach our pinkies inside here and tell whether or not it has eggs.